Start with binomial theorem. We'll start with basics of Pascal's triangle. Alright. See here, Pascal's triangle, if you guys know it, we start with 1. You can say that it is a plus b whole power 0, 1. Next we'll do a plus b whole power 1. Now, if you look at the coefficients of a and b, then we are going to have 1 and 1, correct? 1 into a plus 1 into b. Then we'll do a plus b whole square. A square plus 2ab plus b square. So what are the coefficients? The coefficients are 1, then we have 2, then we have 1. Now, how do we get this one? So Pascal's triangle basically tells us that to get to know the value, see here 1 plus 1 you add, you're going to get 2. Correct? 1 plus 1 is it's going to give you 2. The next one, we start with 1, then we add these two. So what are you going to get? 3. 1 plus 2 is 3. Again, then what you do? You add these two, you write it here. Again, you are going to get 3. Then finally, we write it as 1. What are the coefficients of a plus b whole cube? A cube coefficient is 1 plus 3a square b plus 3ab square. So 3 and 3 plus b cube coefficient is 1. So this basically is Pascal's triangle. So we keep on, adding, we are going to get it. So the next one is going to be 1, then 4, 6, 4, 1. It keeps on going. So that means these numbers, what you're seeing here, they form the coefficient of that particular expansion, isn't it? So the first one, this is for a plus b whole power 0, 1. The next one is for a plus b whole power 1. The next one is a plus b whole square. So that means the last one is for a plus b whole power 4. Likewise, can we get the same thing for a plus b whole power n? Is it possible? This is basically binomial theorem. Okay, now the same thing, now that you have understood, so these are the coefficients. Let me write this in another way with the help of permutation and combination. Not permutation, actually speaking, it's with the help of combination. The same Pascal's triangle, alright? First what we'll do, we'll write this as 1. Okay, the first one. The next one, see you have a plus b power 1, correct? The next one. So that means here we can write this as 1c0, 1c1. What is 1c0? 1. What is 1c1? 1. Correct? So that means here, this is also 1. This is also 1. Both of them are 1 n. What was the next one? 1, 2, 1. Correct? Now what we'll do, we can write this as 2c0, 2c1, 2c2. Now my next question is, why are we taking 2c0? Like, why do we have the 2? Because what is the power here? A plus b whole square, right? See the power? 2. What is the next one? A plus b whole cube. So when you have a power of 3, then what do? We start by taking 3c0, 3c1, 3c2, 3c3. So what are the numbers? 1, 3, 3, 1. So that means now that you have a general sense as to how the coefficients are arranged, correct? That means when you do a plus b whole power n, we start by taking nc0, nc1, nc2, nc3, so on and so forth, correct? This gives us the coefficient of a binomial theorem, or binomial expansion is the right word to use rather than a theorem. Clear? So to expand and understand the coefficient, we say nc0, nc1, nc2, nc3, so on and so forth till ncn. Clear? That means how we can write this one is that we can write it as NC naught, then NC1, NC2, so on and so forth, NCn minus 1, NCn. So these are all the coefficients of a plus b whole power n expansion. Okay, now there is another way how we can actually get the whole thing, but we'll look into it at the end of this particular topic or this particular way, chapter. But right now, what I want you guys to understand is that the coefficients of the expansion can always be given in terms of combination. Okay, NC not NC1, NC like this. Fine. Now in the next video, we'll understand how do we expand it and what is the expanded form and how we are going to prove it.